This is the quiz review for lessons 6.1 to 6.3 for geometry. First thing we're going to do is we're going to find the sum of the measures of the interior angles of a convex sextagon. So there's a formula that you need to know for interior angle sum, which is n minus 2 times 180. N means the number of sides. So if it's a sextagon, we're going to take 60 minus 2 and times that by 180. So we're going to take 58 and multiply that by 180, and we're going to get 10,440 for the sum of the interior measures of the angles. The next one, it tells us the measure of each interior angle is 150, and this is a regular polygon, so that means each angle is the same. We're going to find the number of sides. So again, we're going to use the n minus 2 times 180, but we're going to put it equal to each side and the measure of each angle there. So there's 150 for each angle times the number of sides, so we're going to put it equal to 150 times n. Then we need to distribute to solve for m. So we get 180n minus 360. And we're solving for n, so we're going to take 180n, move it over to be with this side, and we get negative 360 equals negative 30n. And then we're going to divide by negative 30. So we get 12. So n would be 12. Next one is exterior angles. Exterior angles of any polygon are always going to be equal to 360. So if each exterior angle is 72, to find the number of sides, we're going to do 72n, which is number of sides equals 360 this time. So we just divide by 72, and we get 5. So the number of sides of that polygon is going to be 5. The next one, it gives us a parallelogram with G as 4, negative 2. So we're going to graph this. Probably be best to do this on graph paper. So we have 4, negative 2 as our point G. And then we're given the coordinates of the diagonals intersection, and then we need to find the coordinates of E. So if the diagonals EG and FH intersect at 0, 2, that's going to be up here. Sorry, that's my clock if you hear it. So if you have EG and FH, they're going to be intersecting there. We're going to find E is going to be the top left corner, and then F is going to have to be the top right corner, and H is going to be the bottom left corner. So how do we do this? Well, 0, 2 is technically the midpoint of EG. So if we're given G and we're trying to do find E, I would take the midpoint formula, which is adding up the x's, divide by 2. So in this case we have 4 plus something we don't know divided by 2. That's supposed to equal 0, which is the midpoint, and then negative 2 plus y, which we don't know, over 2 equals 2. We're going to solve for x and y now. So we multiply by 2. That gives us still 0. So x would have to be negative 4. and then we multiply by 2 here, we get 4, and that gives us negative 2 plus y equals 4. So solving for y, we get y equals 6. So that would be my other point, negative 4, 6. And that would be E. And as I said before, CE is going to be on the top left. So if we count there, oops. That's going to be up here, which makes it the top left. So that would be our point. So using the midpoint formula is how you wanted to find the missing coordinates there, because we're talking about the diagonals intersecting at 0, 2, and wherever the diagonals intersect is the midpoint of those diagonals. Next one, find the measure of angle 2 in the parallelogram. Here we're going to have to use a little bit of our knowledge of transversals cut by parallel line, or parallel lines cut by transversals. And in this case, if we're given 100 is in the middle, that makes each of these 100. And then to get 100, we're given that 1 is 100, so the other side would have to be 80. And now we're given 2 out of the 3 angles of a triangle. So if we have 56 plus 80, that's going to give us our third angle. If we subtract that from 180, so 136, 180 minus 136 gives us 44. So that would be here. And 44 and angle 2 are opposite angles there. So they're, I've lost my train of thought. Alternate interior angles, I'm sorry. So if you have this as the transversal HF, then we have angle 4, or angle 2 is equal to 44. So that would be our answer. And then determine whether this is quadrilateral or not. Justify. Well, one of the theorems says that to be a parallelogram, we're going to have opposite sides congruent and parallel. We have one of the other, but we don't have both. So I would say no, because opposite sides are not both parallel and congruent. The next 3 we're going to write true or false. So if we think about diagonals of a parallelogram, it says they're never perpendicular, but think about a parallelogram. A parallelogram has opposite pairs of sides that are equal, and that also can describe a rectangle. So if you have a rectangle where all the angles are also the same, then your diagonals are going to be perpendicular. So sometimes they can be. So since it says never, I'm going to say this is false, because sometimes they can. This one, a quadrilateral with 2 pairs of congruent sides is always a parallelogram. I'm going to say true for that one. That's one of our theorems. And then here it says the slope of AB and CD is 2/3. So if we draw this like that, AB and CD, if that is 2/3, and then the slope of BC and AD is -3/2, that's just saying that your sides are perpendicular to each other, which is telling you it's a rectangle, and a rectangle is a parallelogram, so I would say that is also true. And the last one, referring to the parallelogram here, if it's a parallelogram, opposite sides are equal, so it gives us AB is 10, and then in the diagram, it's already giving us that the other pair of sides is 8. So we have 10 and 10 and 8 and 8. If we're doing perimeter, that's adding up all the sides, so we would get 36. And that concludes the quiz review for lessons 6.1 to 6.3.